Welcome to Hope Academy. My name is Mr. O, and today I'm going to be going over the CrackSAT Practice Exam 1 for the Math 2 Level 2 exam, specifically numbers 40 through 42. Feel free to look into the channel to see the prior questions, but how I usually do these is that I go over them quickly and then explain in depth how I was able to do the question. So I'm going to go ahead and get started. So for number 40, the following could be true. Okay. This is definitely a cotangent graph. Okay, so it's not these. Okay, let's check. Oop, did I mess up somewhere? Cotangent x minus, oh, it's degree. Oops. Switch that to radian. Let's try that again. This doesn't cross over. Okay, so for number 40, my final answer is D, and now I'm going to explain to you how I was able to get to this answer. So for number 40, when I was doing this question, the first thing that will help you be able to answer this question is to be familiar with the appearance of a cotangent and a tangent graph. So when we're comparing between a tangent x graph versus a cotangent x graph, you have to understand that the tangent graph will always sort of look something like this, while cotangent will be sort of like the inverse version or the opposite version where it flips around. And so that's why when I was doing number 40 and I saw the choices between A through E, I automatically took out A, C, and E because those questions all had tangent-based graphs, and this is for certain a cotangent-based graph. Now, the next thing I did was that I looked at this question and I was tempted to do transformations and assume that it shifted just pi over 4 to the right or left, but you have to be careful and understand that that sort of rule could become a little bit risky when we're dealing with trigonometry, and so the safest way to do this is by graphing one of these functions. And so on the TI-89, I did graph this out for B specifically, the cotangent x minus pi over 4. Notice that it does not cross on the y-intercept, and thus how I got the answer D. I do also want to note a few other possible issues you might face when doing this question. One of the things is that you have to make sure that the calculator is in radian mode. Originally, my calculator was in degree mode, thus I had to push the mode button on my TI-89 and then go down to the portion it says right here is its angle format, and I changed it accordingly. Another thing is that just make sure your parentheses are correct, and make sure that if you're doing cotangent, at least on the TI-89, you could go to catalog and actually choose C, push the letter C, and then push second down because it lets me skip a little bit faster so I could get to the function of cotangent. If you do not have that option dependent on your calculator, you could always use the tangent function graph. Just make sure you do 1 divided by the tangent of x minus pi over 4, and that will graph you the exact same thing. And thus how for number 40 I was able to get to the answer D. And that concludes my explanation for number 40. So I'm going to go ahead and continue. So 41. Okay. Okay, so for number 41, my final answer for this question is A, and now I'm going to explain to you how to do this question. So vectors is usually a concept based around sort of like lines that originate from the origin, and it talks about sort of like the distance, how far it will take for these lines. But for this question, it's actually a little bit more simpler than just dealing with sort of distances. What happened was that simply what I did right here, when I wrote 3, -4, and -12, -5, is that I understood that if z equals to the negative v plus w, this negative distributes to both the v and the w. And so vector v is this. And I just negative both of these values to make 3 -4, and I negative both these things, which is -12, -5, and I added the x coordinates together, and I added together the y coordinates, and thus 3 minus 12 is -9, -4 minus 5 is -9, and thus how I was able to get to the answer A. And that concludes my explanation for number 41. I'm going to go ahead and continue to 42, but before I do so, I do need to set this up so that you can see the bottom portion of this, since it's on a separate page. So I'm pulling this up, and number 42, I'm going to go ahead and get started. So if that equals to that, then we're just following this. Okay, So I'm going to need a calculator for this question. Okay. So first things first. Okay, so 0.3 times square root 2 pi. Enter. Afterwards. This value. Okay, well, the negative applies to that. So times 2 times this, and then square root answer. Okay, for number 42, my final answer is A, and now I'm going to go ahead and explain to you how I was able to get to this answer. So 42, I mainly did it on the calculator just because typing it in while I already knew which one to multiply and such will make it faster for me to just get to the answer directly. But I will now show you how to do it just separately on a separate piece of paper so you can see what I punched into the calculator, but by hand, just as an example. So right here, they give you my f of x equals to 1 minus square root 2 pi e and then negative x squared over 2. And the first thing they tell me is that f of x equals to 0.33. Okay, and so when I'm doing this type of question right here, what I need to make sure to do is to be careful not to to mess up things or do the wrong sequence. This is what this purely is based on. And so when I was doing this question, the first thing I did was I plugged in 0.33 here and made it 0.33 equals to 1 over square root 2 pi. I'm just copying down exactly what was above, negative x squared over 2. Okay. Afterwards, the next step that I need to do in order to do this question is that I need to get rid of this 1 over square root 2 pi because this is the first function that's going to mess it up before I could deal with this e function. And so to order to get rid of it, I'm going to multiply both sides by square root 2 pi, square root 2 pi. Okay, and so what happened on the calculator when I did that, and I'm just checking my calculator real quick, is that I got 0.82787. So I got something like 0.827 on this side equals to e negative x squared over 2. Okay, and then afterwards, once I got to this step, what I did was that in order to get rid of this e, I need to ln both sides because that's the only way you could cancel out e. So what happens when I ln both sides like this is that this power right here, and I'm going to do it in a different color right here, maybe like a black Sharpie, this power right here is actually going to come down as a coefficient then when I do this log rule because the power rule. So power rule will come into play right here, okay? And so because of power rule and whatever not, what's going to happen is that I plugged in was ln 0.827 whatever not on the calculator, and I ended up getting the value of negative 0.1897 equals to, and this ln thing, whatever not, goes away, and so I have negative x squared over 2. Afterwards, I understood that because both sides have a negative right here, I could cancel out certain values right off due to that, and so I knew right off my next step would just be 0.1897 equals to x squared over 2, just like this. Okay, and now since I'm getting near to the end of this, I just need to solve for x. I can multiply both sides by 2, and that's what I exactly did. And then I got 0.3794. I'm just looking at the calculator, my own calculator, how I got that. These cancel out, so it'll be x squared. And then in my very last step, what I just simply did was I square rooted both sides. So I square rooted both sides right here, and I ended up getting 0.61599 equals to x, and that would be my answer right here. But be aware that because the answer is rounded off in the choices available, you could see that it's going to be 0.62 because it's rounded off to the hundredths place. And thus, that concludes my explanation for today. Thank you so much for watching this video. Please do subscribe to our YouTube channel, like our Facebook page, follow us on Twitter, so that we could continue to make content like this. I hope you have a wonderful day.